So the functions that we were working with in our previous examples were very nicely behaved. We always had one of our functions was an upper function, the other function was always our lower function. What do we do if, as it says here, f at 2 is greater than f at 1 for some values of x, but f at 1 is greater than f at 2 for others, i.e. what happens if over your region of integration one of your functions stops being the upper function and it starts being the lower function, and then the other function takes over as the upper function. How do you sort of evaluate this? Well, what do you think we might do? What do you think, Daphne? Exactly. We're just going to take this, consider these things as two separate areas, A1, A2, calculate the areas separately, and add the two integrals together. So we can say we calculate the areas of the regions and I'll try spelling separately correctly here. Separately and combined. So let's take a look at an example here. Find the area between y equals x cubed plus 8 and y equals 4x plus 8. Again, I'll try drawing a little sketch here of what's going on. X cubed plus 8 is a cubic. So I'll draw it like that. Four x plus 8 is a linear function. These two things are going to have the same intercept. So this is going to look something like this. So y equals 4x plus 8. So we have two areas that we are trying to find. Here to here, and here to here. We'll call one of them A1. We'll call one of them A2. Once again, they don't give us any limits of integration. Okay, so we need to define what our limits of integration are going to be. So step one, find our intersection points by setting our two functions equal to each other. Okay. And from our graph, we can see that we should get three solutions to this. So let's see. Let's bring everything over to the left-hand side, or actually, sorry, to the right-hand side. X cubed minus 4x equals 0. And then we can factor again. And we can factor yet again. 0 equals x times x minus 2, x plus 2. Gets us our three solutions. X equals 0, x equals positive 2, and x equals negative 2. Okay? Which matches up with what we kind of see on our diagram here. We can just add those in now. We've got negative 2 over here and positive 2 over here. Give myself a bit more room here. Okay. So for our first area, okay, what are we going to do here? Let's see. We want to do area 1 is our portion that is on the left-hand side of the y-axis. So we are going to want to do the integral from negative 2 to 0 of, which one is our upper function here? Our upper function is, in this region, it is x cubed. And we want to subtract our lower function, which in this case is 4x plus 8. wait, it's not x cubed, it's x cubed plus 8. Thank you. Oh, sorry. So x cubed plus 8 minus 4x plus 8. And again, we're integrating over dx here. Okay, that makes sense. Good. So what is this going to be? Well, let's see. Integral from -2 to 0. I can cancel out those 8's. X cubed minus 4x dx. I can do my integral, which is going to be, what, 1/4 x to the power of 4 minus 2x squared is my antiderivative. And I'm evaluating this from 0 to -2. So if I evaluate this, give myself even more space here. Evaluating at 0 just gives me 0. So it'll be 0 minus, if I evaluate this at -2, I get 16 over 4 minus, let's see, -2 squared is 4 times 2 is 8. So 0 minus -16 over 4 minus 8, which is just going to give us -4 minus 8, which is just 4. Okay. And then we would do the same thing for area 2. So area 2, I'm going to squeeze it in the corner over here. It's going to be the integral from 0 to 2 of, now our upper function is 4x plus 8. Sorry, I shouldn't do that. I'll move this thing down. The integral from, so now our second region is 0 to 2. Our upper function is now 4x plus 8. Our lower function is now x cubed minus 8. And we're integrating over x. So we get the integral from 0 to 2 of -x cubed what is this? Plus 4x plus 16 dx. Yeah, that's why it's not working out. So that should be a plus. So these two things still cancel, right? So 4x, yeah, that goes and that goes. So we get this integral. Right. So what we're getting, notice, is the opposite of the integral that we had before. Okay. Now, why does this make sense? Well, if we look at our diagram, what can we kind of see about these two areas? Sorry? They're congruent. Yeah, they're going to be the same. Basically, we can use the symmetry of this situation. Tells us that when we're doing this integral, we should get the same thing as what we got when we did this integral, that these two regions are actually the same. Okay. Let's actually work out this integral and sort of verify it. It is going to be the integral from, hold on, what did I get here? 0 to 2 is negative, right? So negative no, sorry. Doing that backwards, right? 2x squared. So our antiderivative is going to be -1/4 x to the power of 4 plus 2x squared. We're evaluating this from 2 to 0. When we evaluate it at 0, we're just going to have 0. So we just really need to evaluate it at 2, which is going to give us negative 16 over 4, so negative 4 plus 2 squared is 2 times 2 is 8, which is 4. So finally, we can add these two areas together to get our total area. So we'll just say A total equals 4 plus 4 equals 8. And we are done that. Okay. All right, so the last example I wanted us to do was one that you would probably have to do numerically. Okay? Find the area of the region bounded by y equals x over root x squared plus 1 and y equals x to the power of 4. Okay? You can't do this. I can't do it algebraically. I don't know. Maybe you can. But so this is a question where you would basically have to use the graphing calculator that you have access to. Okay? So we'll do this one kind of together. I don't think I'm going to record it. But the steps are still the same. You're going to use your calculator, whatever calculator you're using, to find the intersection. Okay? And then you're going to use the intersection that you get from the calculator to evaluate your integral. Okay? And the integral that you're going to do is the integral over, well, whatever your two limits are, x over root x squared plus 1 minus x to the power of 4 minus x over dx. This is our upper function. This is our lower function. How do we know that? Well, we know that because we just did a graph on our calculator. The answer that we should get when we do this is 0.785, approximately. Okay. 4. I've written 1 there. I have x in my notes. Okay. So we'll change that to x. Okay. All right.